For mechanism reaction, we said that in reaction mechanism for alkanes and alkenes as a comparison, at the beginning for alkanes and alkenes, we said that for alkanes, the reaction, the type of reaction as free radical substitution, and the type of vision is the mechanism, and for the vision, we said that the vision is homolytic vision. In case of alkene, we said that the reactions are electrophilic addition and the type of vision, heterolytic vision. After that, for the reaction, for example, if you have CH4 plus Cl2 gives CH3Cl plus HCl, and then write the mechanism of this reaction. At the beginning, initiation, that Cl2 it change into 2Cl free radical, and after that, if we need to write the Kelly arrows, it would be like that. This is the initiation, that the molecule will change into 2 free radicals. Number 2, propagation. In propagation, you will find that the molecule reacts with the free radical, CH4 will react with the free radical to form CH3 free radical plus HCl. After that, CH3 free radical will react with the other molecule with Cl2. It will form CH3Cl plus Cl free radical. Termination, the final step, CH3 free radical with the other one free radical to form C2H6, or Cl free radical plus Cl free radical to form Cl2, or CH3 free radical plus Cl free radical to form CH3Cl. This is a mechanism for alkanes. Mechanism of alkenes, like CH2 double bond CH3 and H, reacting with HCl to form CH3 CH CH3Cl, to be like that. And then we need to write the mechanism. For mechanism of the reaction, C double bond C, and then CH3 H H H, reacting with HCl. On adding a symmetric reagent to asymmetric alkenes, you will find that HBr, they are different asymmetric reagent, and asymmetric alkene, C contains 2 hydrogens, the other C contains only 1 hydrogen. In this case, the positive part will take the carbon will take positive part that contains more hydrogen. In this case, C contains 2 hydrogen and the other one hydrogen only. So the positive part is partial positive and the partial negative. Kelly arrow and the other Kelly arrow. Then the addition will be C single bond C, and then H will be with the greater H, and Br will be with the less amount of H. So double bond will be single bond, and then adding the other side positive charge. Then CH3 and H plus Br negative with lone pair. After that, Kelly arrow to become CH3, and the other one contains CH3, H, and Cl. After that, for reaction mechanism between halogen alkanes and aldehyde and ketones. Aldehyde and ketones by the same way. For mechanism of the reaction, in case of halogen alkane, you will find that nucleophilic addition. This for a nucleophilic says for substitution, in this case for halogen alkanes, and nucleophilic addition in case of aldehyde and ketones. Why is this addition and why is this substitution? Halogen alkanes, like alkanes, all of them contain single bond, so the reaction must be substitution. And aldehyde and ketones contain double bonds, like alkene, so it will be by addition. So for the reaction, both of them, halogen alkane and aldehyde and ketones, are nucleophilic. But in case of alkanes, nucleophilic substitution. While in case of aldehyde and ketones, because it contains C double bond O, it will be addition. After that, for the reaction mechanism, for example, if you have C and other C, the other one is contains 3 carbon atoms, and then this contains Br as a halogen. And then we need to add hydroxyl group. This hydroxyl will be negative and contain lone pair. In this case, by adding Kelly arrow, it will change to unstable compound, and then the three hydrogen to be the same, and the other one, it will be this one, and the other one, 2 hydrogen will be the same, and then making dashes for the Br and OH. These dashes for Br and the other dash for OH. This unstable compound, that one of them must be getting out, so you'll find that hydroxide will replace the Br to be the first one to be the same as it is, and the other one it will be contains OH instead of Br plus Br negative. For mechanism of halogen alkanes, we said that nucleophilic substitution reaction. For SN2 in primary and SN1 in tertiary, substitution nucleophilic and 2 to the rate of the reaction, and tertiary to be different from the primary to take another rate, SN1. And in case of SN1, we have 2 steps, slow reaction and fast reaction. In the first one, we need to enter OH instead of Br. So in this case, there is a molecule, and we will make Kelly arrow from OH that contain lone pair and negative charge to the carbon. After that, we will make a slash for the OH and Br, because each carbon contains only 4 bonds. So we have 1, 2, 3, this 4th and 5th, and this unstable compound. After that, OH will displace the Br, so OH will form a bond, and then Br will be replaced to be by the negative. So we replace the OH negative to be Br negative. This is in case of tertiary, in primary, sorry. After that, for tertiary, we have SN1, a slow and fast reaction. You will find that C combined with 3R, and there is no H's. So we'll make partial positive, partial negative, and then kill the arrow between C and Br. This is a slow reaction. After that, OH will enter for the C that contains positive charge, that contain lone pair and negative charge, carry out to C that carries a positive charge. This is the slow reaction. For the fast reaction, OH with lone pair and negative and the positive charge will forming a bond to be C with OH, and Br will be replaced to be Br negative. After that, for aldehyde and ketone, the reaction as nucleophilic addition. C double bond O, partial positive and partial negative, and we will add Cn negative. So you'll find that at the beginning, curly arrow and partial positive, partial negative, and other curly arrow from Cn that carry negative charge and lone pair. After that, it will be double bond, will be single bond, and Cn will be entered, and O have lone pair and negative charge. After that, you will find Cn with O that contain lone pair will react with another HCN. O combine with H to form OH, and Cn will be negative charge and lone pair being get out. So we have C, Cn, and OH. So we replaced C double bond O when reacting with HCN to be COH Cn.